5. Bicycle rider riding 5 kilometers east, resistive force west. Turns around and rides west. The resistive force now points east. All right. All right, so let's see. Find the work done by the resistive force during the round trip. Well, look, we know that no matter what the case is, we got the bicycle rider going one way and the force going the other way, right? In each case. So we got force, and we got displacement, which is our 5 kilometers or 5,000 meters. We got a resistive force going this way, 3 newtons. All right? We know that the work done by the force is going to be equal to F dot D as vectors, or we want to make it so we can calculate it mathematically, FD cosine theta. Well, what is theta in this case? In this case, no, it's not 0. It's 180, okay? And what about when he rides back this way, and the force is this way of 3 newtons? All right, and here's D of 5 kilometers. All right? And what's the angle in this case?
180.
Also 180. So you can see that in each case, the work done by the resistive force is going to be what? It's just going to be negative, right? Because that means work is equal to negative FD, because cosine theta here, cosine of 180 is going to be negative 1. All right, so in each case, it's going to be the same each way, right? We don't need to calculate it twice. We could just say that it's 2 times, negative 2 times the force times the distance. It's going to be negative 2 times the force of 3 newtons times the distance of 5,000 meters, 5 kilometers. Everybody can do that in their head, right? What is it? 6 times 5, 30. 30,000. What do we get when we multiply newtons and meters? Joules, we do. All right, so this is the grand total. Now, let's not forget the negative. All right, so that's the grand total for the work done by the resistive force during the round trip. All right, so now the question is the resistive force a conservative force? What's your first thought? No, okay? Do we have evidence that it is not a conservative force? There are two ways that we define conservative force. One is that work done is independent of path. And the other, which is sort of a corollary, but it's the more important one for answering this question, work done for delta x equals 0, let's say. Okay? In other words, if you start one place, you come back to the same place. All right, we should actually do this delta r, because this is true in no matter how many dimensions you talk about. Okay? So it's a closed loop is the way it's defined in your book. It says the work done when an object travels in a closed loop by this force would be 0. But it's not in this case. It's rather large, and it's negative. Okay? So, since this is not true, then force is not conservative. All right, that's that. Any questions on that?